But now we're going to delve into more of what this particular course is about. And if anybody wants to follow me, pretty much, now we're going to go back to Excel in a minute. Page 325-ish, or 325, 326, if you kind of want to follow along. But I'm going to set the groundwork here so we can kind of know where we're going. Now, I'm going to say, we're going to call this multiple linear regression. And if you have a general clue about simple linear regression, which is what we just did today, then multiple linear regression shouldn't be too much of a shock. Now, the good thing about linear regression, probably from your perspective, is you don't have to struggle and deal with the summation of anything. We're going to let Excel do all the work, and we're just going to have to make sure we know how to interpret these results. Okay, so all that summation, this summation, that was kind of limited to simple linear regression, but multiple linear regression, we're going to rely on Excel to do this stuff. So let's start by terms of definition. Let's say definition. And let's say multiple linear regression. Because I'm lazy, I'm just going to say MLR in the future. Nobody got time to write all that stuff every time. Is a statistical technique. Is a statistical technique that uses several explanatory variables to predict the outcome of a response variable. Okay. So this is kind of what you might expect, and we're going to try to clarify it. So this is an extension of simple linear regression, because as we just saw with the problem that we just did, you had an X column and you had a Y column. But truth be told, in real life, that's not how it works. A lot of times there are several factors or several explanatory variables that contribute to a response variable. For example, let's say I'm trying to lose weight, okay? And you want to look at different things that are contributing to whether you're losing weight or not, right? The why in a sense. So let's say Y is pounds lost. Let's say that's the response variable. Well, there are different things that could affect that. Now, give me an example of what could affect, and it has to have like a number attached to it. What could I be doing, or what things could contribute to whether the pounds come off or not? Give me an example. I'll give you one to start off with. Number of calories I eat, right? So that's one thing that could contribute to weight loss. What else?
Exercise.
Very good. Amount of exercise that I do, and you just have to figure out a way of quantifying how you want to do that, whether it's miles run or whatever. But yes, so the exercise could be that. What else? We're just thinking out loud. What is another variable that could contribute to whether I lose weight? Oh, I don't know. Some people say, and this may not, maybe you don't get this, or maybe you don't agree with it, but actually the number of hours that you sleep, right? because they say it has to do with metabolism. Yeah, okay, so exercise. Yeah, some people say it has to do with like metabolism and sleep and giving your body the. So in other words, it's not just one thing that's predicting my outcome. So that's what we're going to look at with multiple linear regression, is that there could be more than one of these things that contributes. All right, so we're going to take a look at the model, the mathematical model that bears that out. All right, but that's in general the idea. It's not just one column. So I'm going to say note. We still have a regression. We still have a regression equation. It's going to change how it looks. It's going to change what it looks. So I'm still going to say y sub L. I think we remember the last time when we did this L right here, it had to do with like linear, like a linear model, or that use it to predict. It's going to look like this. It's going to make sense. M1 x1. This is normally the slope. We normally do mx plus b. But watch this. That's the first variable that could affect it. M2 x2. So this could be calories. This could be amount of exercise, right? Plus, and you keep going. Like there's no limit to how many of these you can have. So you can have 3 factors you're talking about. You can have 4. But I'm just going to say dot, dot, and so forth and so on, right? So this would be the first one, the second explanatory variable, the third one, and you can go up to however many you have. So this one, right, this dot, dot, dot just means that's as many as explanatory variables as you have, and then plus b, your y-intercept. So as opposed to just y equals mx plus b, you have y equals the first slope, the first variable, the second slope, the second variable, the third one with the third one, the 26th one with the 26th. It just keeps going on. And so this dot, dot, dot stops when you have considered all of the x columns that you're considering in that problem, right? And then finally, that y-intercept. All right, so just in terms of figuring out what these are, we're going to say number 1, M1 is the slope of y with variable 1. See, this M1 is the slope of y with the variable x1, comma, holding all other x is constant. And I think that'll make sense a little bit later as we move forward. In other words, this definition is playing into effect. Like, say, for example, in our example of weight loss, like, how do you know whether this one factor is working or not? How do I know if the amount of calories is affecting my weight loss, given that there are other variables in the mix? So we're going to figure out how to interpret this thing right here, right? Now, in real, well, I'll get to that in a second. Number 2, M2, for example, is the slope. It's still a slope. The slope of y with variable x2 holding all other x's constant. Okay, holding all other x's constant. All right. So don't worry if you don't really understand yet when it says holding all other x's constant. It'll make sense when we do a problem. But I think you guys are okay with just the general setup of what the regression equation looks like, right, and how it extends upon what we already know. Now this b here, let's write down the definition for b. So I'm going to say number 3 here. B is still the y-intercept. B is still the y-intercept. Okay? All right. Now, I need to figure out kind of how this graph looks. And I'm never going to ask you to draw a graph or a scatter plot that relates to this, but I at least want to show it to you kind of how it would look. And if you want to kind of look with me, look on page, see if I can find it. I think I have it here. I really wanted you guys to see this. Oh, darn. Okay, if you look on page 334, look on page 334. Again, I'll never ask you to do this because Excel just does not have the capacity to draw graphs like this. I had to use a separate program when we were writing the book, a program called Jump, JMP, which allows you to see stuff in like 3D, right? But say, for example, in fact, I want to show you something. This is going to be a problem that we do in a second, but I wanted you to at least see it. Take a look at that. You may have to zoom it in a little bit. Now, this is a problem that extends upon. I don't know if you guys remember when we first introduced simple linear regression. We had a scenario where we had foot traffic and then sales. So now what I did was I added a column, minutes open. And if you read the little blurb there, what we're trying to do now is predict sales based on like how many people come into your store within a certain amount of time. And then also we're going to look at this other variable of how long does your store stay open after closing. You know, like businesses, they say they close at 2. They may not close right at 2 if their customer's still in there. So that's the other variable we're going to sort of look at. But look at, for example, how the data is posed. You see foot 29, minutes open 17, and sales 312. So now we have 2 explanatory variables, which are foot traffic and minutes open, but we're still predicting sales. So I don't know if you guys can see this. I'm going to write this right here. 29, comma, 17, comma, 312. Okay? So that's just one of the points. And I'm going to exit this out. So in other words, what I want you to see here is as opposed to having x comma y, we essentially have this x1 comma x2 comma y, right? And if I had to draw this, it's almost you're gonna have to sort of visualize this with me. You see this, you see that. That's normally what we do when we plot. But now with regression, especially when you have something like this, 2 explanatory factors, it adds another dimension. So think about like the corner of the room. You know, you have like this part of the wall, that part of the wall, and this part of the wall here. So what it does is that when you plot a point, let's say, for example, I don't know, let's say this is the first like 10, 20, 30. That's for this first one. Over here, let's say 10, 20, 30. And up here, we have something like 100, 200, 300. So then when I plot this point, I'm going to 29, 17, and then up in the air, 312. So it's like the point is sort of like in mid-air. So do you how like on page 334 and 335, it's trying to give you a sense of the 3D kind of effect. It's hard to draw on the board. I know you can't really do that, but essentially you just have all these points sitting in air, as opposed to like on the floor, which is like 2D. And when you try to find the best regression line, it becomes a regression plane. So can you see like on page 334 and 335 how you're sort of doing like it's not a regression line of best fit, it's like a regression plane of best fit, like a sheet of paper, trying to figure out what goes there. But don't worry, I would never ask you to kind of do this, but I have to at least kind of show you like where that's coming from. All right. So here's what I want us to do. I want to take a look at the data. In fact, the handout that I just showed you, see if you can go ahead and put that up, because we're going to solve the problem and go over definitions kind of as we go along. All right. And I'm going to teach you how to do it in Excel. So you're going to struggle again. with Excel. So open up a fresh Excel sheet and just call it something like, I don't know, handout or something like that. But we're not going to turn this in. We're not going to turn this in. So I'm going to open mine, then I'm going to try to share my screen with you. But it should say handout on multiple regression. Let's see here. Share. Okay. So hopefully you can still see me in the bottom. I'm not going to worry with Loom. That really gets on my nerves. Okay, so I'm going to say handout. Handout here. And you can say MA321 if you want. So what we're going to do, we have foot traffic. So we need to go ahead and put this data in. Minutes open and sales. Notice already we see we have more than just one X column. So let's go ahead and put those in there. Let's see, foot traffic. Give me 1 second. Go ahead and put yours in while I put mine in. Let me find this here. Handout. Oh goodness, don't do this to me. All right, give me 1 second. All right, 29. So let me go and put these things in there. 49. Please make sure you enter the data correctly because that's going to affect our results. 17, 41, 62, 2. This is exactly the same data that we had last time, except I stuck a column in here. 500, 799, 102. Okay. All right. Now, I'm going to have to close this out, but keep yours handy because we need to sort of go through, be able to answer all these questions as we go. But I need to get out of here, and so I can share my screen with you, Excel. All right. Okay, everybody should have the data in. So what we're doing is, so let's label these. So this sales, this is still the Y. That's still the response variable. And it doesn't matter which one of these we call X1 and X2. That's okay. I'm gonna just call this X1. I'm gonna call this X2, right? But do you see here where we have more than one X column that's contributing to sales? So it's not just foot traffic. Okay, so let's figure out how to do this in Excel. You already know how to do it, believe it or not. Let's go to data and open up the tool pack again, data analysis. Click on regression. It's the same thing we did this morning, exact same thing. Now, okay, so you guys probably can't see, yeah, okay, so you can only see the Excel tab. That's okay. Input Y range. Do the same thing. Click inside of Y range and highlight from sales, the word sales to the 102. So not the Y, not the Y. So it's the same thing we did last time, sales there. Now, this time, click inside of input X range. And I know you can't see what I'm doing in terms of the regression, but so ordinarily, we would highlight, for example, we would just highlight those right there. But that's incorrect. So delete that from input X range. What we're going to do now is we're going to highlight all of this stuff as input X range. So all of the X values, so foot traffic, minutes open. I'm going to highlight all those as a block. So not just one column. All of the X values there, including the titles. Now click on labels. Click on labels. And as we did the last time, click on output range. And then make sure the cursor is kind of blinking inside of that output range thing. And then tell Excel where you want the data to appear. Now I'm going to choose, I'll choose right under it. I'm just going to choose mine right here. And see if press OK, and see if your system gives you some results. I hope so. I hope so. Let me pause here, see if your answers match, or see if you're getting results. Look like
mine didn't work. It says alert regression input range must be a single row or column.
Yeah. Now did they happen for the Y or the X's?
It doesn't say. It just says alert. Like it just says what I told you.
Okay, so start over, clear it, exit out, go back to data analysis.
Okay.
All right, click on regression.
Okay.
All right, now did you see where it says input Y range?
Yep, and then you just do the sales.
Yeah, so just do the sales all the way to 102.
Yep, and then for the X range, you would do all of foot traffic and all of minutes open, right?
Yeah, and then go down to the last piece of data there, and then make sure that labels is checked.
Okay. All right, let me do it again.
And do output range, and then click on where you want the data to appear, and then do OK.
Okay, it worked that time. I don't know. I may have done something weird last time.
All right. Is everybody with me? And again, this is where I could be walking around in the class and looking at everybody's, but I'm hoping everybody is with me here. Is everybody has this data staring at them?
Yes.
Okay, intercept. Okay, good. So what we're going to do, so that's step one. That's going to cut out all the solving stuff by hand. You've got to at least get here to be able to understand where things are coming from. Now, what's the first question that it asks on that handout? It say something about independent variables. What does it say?
Which of the variables are the independent variables and which are the dependent variables?
Okay, all right. So let's see. Remember, independent is explanatory. So for number one, I'm guessing you guys can see me here. For number one, we can solve this even without Excel. Independent variables in this problem are what? What are the explanatory variables, or ones that are used to predict y? What would you say the independent variables here are in our specific problem? What other variables that are predicting our y?
Foot traffic and minutes open.
Very good, very good. So this is foot traffic. That's the first one. And then minutes open is our second one. And we call this one x1, and we call this one x2. All right? So we have two independent variables, and our dependent variable, or our response variable, is what in this problem? What are we?
Sales.
Sales. Very good. Very good. Okay. So there could be two of these. There could be three. I don't guess I'll torture you with 4, but so what? Even if I do, I mean, you put it in Excel anyway. If you have 4 explanatory columns, then that means when you do the regression, you just write those 4 columns all together, just like we just did those 2. Okay, well, what does number 2 say? What's the question for number 2?
Draw the scatter plot.
Okay, skip that. That's like if you had to draw like the 3D image, right? So I would never ask you to do that, but that's where I wanted you to sort of plot the difference. I think it's 4 points here, so you end up with just 4 points suspended in the air. So let's skip to, what does 3 say?
Write the equation for the line.
All right, so let's see, MLR equation. All right. Now, how do we normally write the equation for linear regression, for simple linear regression? We went down to the bottom, so look at your data there. I want to kind of blow this up if I can. You may have to blow it up on your own screen. Where did we find the values when we wanted to write the regression equation? When we did it on the 2-pack, like in the simpler case. We found it in the bottom, I think. You see where it says foot traffic down at the bottom, minutes open in the bottom, and then intercept? So that's what we're going to use to write the equation. Now, those values that you see, for example, that foot traffic, that's the first slope. That's M1. All right? So our equation is going to look like this. 0.92. Somebody guess what I'm going to put right here. 0.92 what? Think real carefully. What's the general form of a multiple linear regression equation? We wrote it earlier. M1 what?
X1.
X1. Very good. Very good. Now let's continue. Look at the data, the results, plus, we're going to say plus 9.91. See, that's the value down there beside minutes open. And then what beside here? 9.91 what? Look at this. Look at this. 9.91 X2, right? See, the general form says M1 X1 plus M2 X2 plus dot, dot, dot. Well, we don't have to write dot, dot, dot because our dots stop at 2. We only have 2 columns. If there was a third one, I have to write that third one. Now, who can tell me how to finish the equation?
Is there another way you can show us the equation, because the board, the video is like less than 1 by 1 inch. It's tiny and we can't read it.
Oh. Okay.
Just click on his picture and it'll bring it up. It'll just switch screens.
Thanks.
Okay, is that better? Are you able to see better?
I knew you could switch them like that, so thank you.
Okay, all right. Yeah, I don't want to just be a little tiny kind of afterthought. So we have 0.92 X1 plus 9.91 X2, and what? What's the final thing I need to write?
The y-intercept or the b.
Good. So in this case, it's going to be what? Plus what? According to the results.
75.09.
Good. 75.09. Okay. So in other words, I want you to see the different parts are always there. Yes? So this is our regression equation. So if I give you a problem like this, and I give you like the data, and you do the regression, I say, what is the regression equation? That's what I'm looking for. This x1 plus this x2 plus this. Now, of course, if they end up being minus, you just put the minus wherever it goes. Like if this were like a minus 9.91, you put that minus right there, right? But the regression equation always comes from that part, from this, from these values right here, right? What's the next question? What does number 4 say? Does it say something about the slopes?
Yeah, interpret the first slope, M1.
All right, here we go. So I'm gonna say number 4. Well, according to what you see, now if I rounded this off, should it be? Oh, I guess this should be 0.93. I mean, I don't really care that much, but if I'm gonna take it 2 decimals, I'm just gonna write it at 93. Or you can leave it as 0.92. It doesn't matter. But looking at this equation, what is the first slope? Don't think too hard. The first slope, the value of the first slope is what?
0.93.
0.93.
93. So M1 equals 0.93. Now we have to interpret that. Everybody's favorite. Let's interpret this. Now, we saw how we did it on exam 1. For example, this number right here is really equal to 0.93 over 1, right? And you remember how we did last time, like on the exam? For every 1 hour you spend on TikTok, GPA increases by blah, 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 blah. Just check out the solutions for that, right? But we need to figure out how to interpret the slope in the case of multiple regression. And so now this goes back to what I was talking about in terms of holding certain variables constant. I'm gonna go back to losing weight, then we're gonna get back to this. I'm not obsessed with weight, but it's just easy to kind of think about. Okay, think about this. Think about this. If I want to interpret, or if I want to see how effective my calories are on losing weight. So let's say I'm looking at calories, I'm exercising. Let's just say those two in terms of my weight loss. If I want to get at how effective the calorie part of the equation is, do you agree that in order for me to kind of figure out what's going on with calories, I have to keep doing what I'm doing in terms of exercise? Whether it's 1 hour a day or 2 hours a day. In other words, I have to fix the effect of exercise. I have to keep that steady and then kind of analyze, okay, let me change how I'm eating, kind of see how this affects it. But in other words, when I interpret the calories, it's not really going to make sense for me to also change the amount of time I'm exercising. If I'm exercising 2 hours a day, I need to keep doing that and then on the calories to see how that, I hope that makes sense, right? Likewise, if I want to measure how effective my exercise is, then what I have to do is hold steady or keep constant my diet, whether it's good or bad, right? If I'm eating cheeseburgers every day, then I have to keep eating cheeseburgers every day. I have to keep that the same and then alter my exercise so I can kind of see how my exercise is contributing to my weight loss, right? So as I interpreted that, when I interpret this first slope, I'm going to have to keep the effects constant of what I'm not asked about. Okay, so let's write this first slope here, the interpretation. Now it's still delta x, it's still delta y over delta x, right? Y is over x. So here we go. Now M1 goes with X1. What is X1 here? Foot traffic. So the one that I'm not asked about is what? Minutes open. So see if you can follow this logic. For a constant time that stores remain open beyond closing, comma, where did that come from? So this is pretty much the wording that I'm using for the column for minutes open. And you have to read in the narrative what minutes open means. Well, in this example, minutes open means what? The amount of time that stores stay open beyond closing. So what I'm doing is I'm fixing that effect because they aren't asking me about it. See, this 0.93 is really talking about foot sales or foot traffic, not foot sales, foot traffic. See, this 0.93 is for this y, and this number on the bottom is going to deal with this x1. The 0.93 is a number beside foot traffic. So what I have to do is fix the effect or make constant what they're not asking me about. All right, so now here we go. For every one customer that enters between 1 and 2 p.m. So let me stop here. So when I say this right here, this is now interpreting this number 1 right here in light of what it represents in terms of the X1. But what is X1? Represents foot traffic. You sort of read about what foot traffic means. So for every one customer that enters between 1 and 2, sales are expected to increase by what? What do you think? Are expected to increase by what? Look carefully. For every one customer that enters between 1 and 2 p.m., sales are expected to decrease by, the answer staring you right in the face.
93 cents.
93 cents. See, this number right here is the denominator, and this number right here is going to be the numerator. Now, again, what does the 0.93 represent? It represents what's going on with foot traffic, because the M1 is paired with X1, right? So what I have to do, see, normally you're cool without this part here. I don't want to scratch through it, but when I scratch through this part makes sense. It's what you're using, right? But I have to add this part here because it's saying, okay, well, you aren't really asking me about minutes open, so let me keep that number constant, or let me fix the effect of that, and now I can start telling you about what you really are asking me about, right? And that's this 0.93 as relates to foot traffic and sales. Struggle through yourself. I want to see what you can do by yourself. Interpret the second slope. Well, what is the second slope? The second slope, M2, what was it? 9.92, 9.91, something like that. Struggle through. So this M2, now this is what minutes open. So eventually I got to say something about minutes open and sales, right? Because they're all predicting sales. But when you write it, fix the effect or hold constant the effect of what they're not asking me about, like the other variables. So everybody struggle through that.
Wait, Professor, the screen won't focus. Do you think you could read that?
Okay, let's see. Read this sentence here, or the bottom.
If you could read that, what you wrote.
Okay, sure. For a constant time that stores remain open beyond closing, comma, for every one customer that enters between 1 and 2 p.m., sales are expected to increase by 93 cents. That's dollars, 93 cents. And the only thing I have down here is second slope. I say M2 equals 9.91. So what everybody is struggling with now is trying to write an interpretation for what that means. 991.
Thank you.
So you want to hold constant the effect of the X that they're not asking you about, and then go for the gusto in terms of that 9.91. And I mean, it comes with practice. So, so what if you don't get that answer totally correct? Dana, you want to take a stab at it? Want to take a stab at it? If you're right, you're right. If you're wrong, you're wrong. Is Dana in here?
I am sorry. I was catching up because the screen was blurry.
Oh, right. Oh, okay. Sorry about that. Is it better? Well, I don't have anything. Did anybody was anybody able to struggle through that second one? It's going to take some getting used to. 2 is 9.9. 9.91, 9.92. Lydia, did you get anything?
Sorry,
Or
I'm trying to like reread what it's asking to understand because I know we're holding something constant to see
right.
how every
Yeah. What are we going to hold constant here in terms of the column?
we're holding foot traffic constant.
Right. So we're going to say something like for a fixed, and again, it doesn't have to be verbatim. It doesn't have to be verbatim. For a fixed number of people who enter between 1 and 2? Between 1 and 2? Okay. Now, we took care of that. What we're going to say here, so this is like 991 over 1 for every what? Let's see. And I'm going to write this like this so we can just kind of see. If you have a different color, that may be helpful. I'm going to 991 over 1. And every time I reference the number in here, I'm going to make it that color. For a fixed number of people enter between 1 and 2, for every what? For every
one person that enters the store, sales would go up by $9.91.
almost, because see, okay, so that's good because see, we took care of the people who entered the store in the first part here. So now we're looking at sales and what?
Every minute the store is open.
Yes. For every 1 minute, what? The store
Is
open beyond closing.
yes.
See now, because see what's happening here. See what's happening here is that. Oh, I'm sorry. I should have wrote M2. See, this M2 here is now focusing in on sales with the column of X2. So this thing we fixed right here is that we essentially fixed X1, that first column. So now the explanation here has got to link what minutes the store is open and what? For every 1 minute the store is open beyond closing. How would you put this? I'm listening.
Is it overtime hours? Or minutes? Is it,
I'm sorry. I'm just reading everybody saying they can't see. Okay, I'm sorry. Okay, so yes, so for every 1 minute the store is open beyond closing, what? The why? What's the why?
Sales.
Sales. See, in the M1 interpretation and the M2, I'm saying something about sales. Because see, this is still like essentially y over x, right? So the y is still going to be related to this part here, delta y over delta x. So sales are what? What would you say? Sales are expected.
increase by $9.91.
There we go. Expected to increase by $9.91. See, in both problems, you're still predicting sales. Like, the last part of the interpretation is still sales will be expected to increase or decrease. But the first part of it changes depending on whether I'm asking for M1 or M2. If I'm asking for M2, I'm going to fix the effect of X1 and get that out of the way. And then my interpretation is going to be with X2 and Y. Whereas in the first example, I fixed the effect of x2 and made the commentary here about x1 and y. Yes.
Since it's just so blurry and can't read it, can you please read the interpretation out loud for a fixed number of people who enter between 1 and 2 p.m. continued?
Yes. So after that, it says, for every 1 minute, the store is open beyond closing. For every 1 minute, the store is open beyond closing, comma. Sales are expected to increase by $9.91. Now, of course, if the y-intercept is negative, then you'd have to say sales are expected to decrease by $9.91.
Professor, I'm just like a little confused about like the first sentence for each one. Like I know you just explained it, but I don't know, it's still just like not making sense to me.
You know, the first part of the sentence?
Yeah, like why is it like why is it different for slope of M1 and M2?
Right. So in other words, if I want to interpret M1, which is paired with X1, you know how it has M1, X1?
Yeah.
If I want to compare, let's see if I can do it like this. And I don't know if you're going to be able to see it because the board may be blurry, but give me 1 second. So you have essentially, you want to interpret M1, for example. So if I'm interpreting M1, I have to consider X1 and Y in my interpretation, right? But the only way I can interpret X1 and Y in terms of the interpretation, I have to fix the effect of X2, which is what I'm not being asked about. And it had to do with the example I told you about losing weight. If I keep changing, for example, if I keep changing, or if the amount of exercise fluctuates in my life, I exercise 1 hour today, 30 minutes tomorrow, 5 hours the next day, right? And let's say my calories sort of go up and down. The only way I can focus on giving an interpretation to calories is if the exercise part becomes constant. 2 hours, 2 hours, 2 hours, 2 hours, 2 hours of exercise a day. So when I fix the effect of exercise, it now allows me to make an intelligent conclusion regarding my calories. But if both variables keep fluctuating, I can't really give an interpretation for calories, for example. So that's all I'm doing here is when I want to interpret M1, I fix the effect or hold constant of what I'm not being asked about, in this case X2, then offer the explanation based on X1 and Y. If I'm given M2, I have to now give an explanation for X2 and Y. Then I have to fix the effect, and I don't know if you can read this or not, fix the effect of X1, which is the variable that I'm not being asked about. Okay? So I mean, it's going to take some time to get used to it, but essentially the strategy is when you have to interpret the slope, you have to fix the effect of the variables, the X variables that I'm not being asked about, and then offer interpretation for the variables that I am being asked about. I mean, it'll come with time. And when you guys do your homework, matter of fact, problem set 6 will be there by the end of the day today. So you're going to have some more opportunity to kind of deal with it. But I mean, it's the exact same thing we kind of did with simple linear regression. The only thing now is that since we have these extra variables, you have to hold constant what you're not being asked about, and then struggle to make some kind of interpretation of what you are being asked about. But notice in both cases here, the end part of the what you write always has to do with the same Y, sales. The only thing that changes is like the first parts there. Okay? So it'll take some getting used to. And if you look on page, look at page I always like to show you this stuff. On page 329, this kind of gives an interpretation or gives you more insight into where this is coming from. So actually page 330. Page 330. So there's a regression equation down there. And I think they give certain interpretations for the slopes there. But just make sure you read the section 329 and 330. That should kind of shed some light on that. All right. So again, it's not obvious. I think it'll come through time. Just practice holding constant the effect that was not being asked about, and then struggle through with what they are being asked about. But just know that in both cases, your Y, in this case sales, will always be sort of the concluding statement. All right, what's next? Do they tell me to interpret the Y-intercept next? On the
Yeah, it's the Y-intercept.
All right. Now, let's write a strategy for doing this. And notice how all of this is like no math at all. Don't you just love being in the math class when you're not really math? But yeah, so you're going to have to rely on your analytical skills, though. See, it's called data analysis. What's called data analysis? So let's say interpreting the Y-intercept. All right, so I'm going to say as a strategy. So let's say strategy. Check to see in this particular case, if x1 equals 0 and x2 equals 0, or x3, depending on how many x columns you have. I just stopped at 2 because in this case we have 2. Check to see if those values are both in the range of their columns. Check to see if x1 equals 0 and x2 equals 0 are both in the range of their columns. Why am I saying that? Because the y-intercept, remember in simple linear regression, the y-intercept is always 0, comma b. Remember we talked about that? Well, in this case, the y-intercept is, guess what? 0, 0, comma b. So before I can offer an interpretation, I need to make sure that 0 is in the range of foot traffic data. Everybody look at that foot traffic data. Is 0 in the range of this data here? I don't have it in front of me.
No.
No.
It's not. It's not. Look at X2. Look at minutes open. Is 0 in that range? I don't have the data.
No.
No. Okay. So what do you think that means in this regard? In terms of the interpretation. So I'm going to say no. Now, when I say no, that means either 0 is not here or 0 is not here. In order for me to offer interpretation, 0 has to be in this range of foot traffic, and it has to be in this range of minutes open. If it's only in one, then that doesn't cut the mustard. So I'm going to say if both conditions do not hold, in other words, if 0 is not in this one and this one, if both conditions do not hold, we do not offer an interpretation. So in fact, in this particular problem, we can't offer an interpretation. right? Because you have to do the check. Is 0 inside of this column? No, stop. You don't even have to check the second column because it has to be in both. You look in this one, foot range. Oh, good. 0's in that. And remember, when I say in the range, 0 very well could be one of the data points, right? So if 0 is one of the data points, then that's a check mark. It counts. Then go to this other one. Is 0 in this range? No, I can't give you an interpretation then. Yes. Yes. If 0 is in this one and in this one, it has to be in both. If both, yes, are in the range. I'm listening.
So since the y-intercept is 0, 0, b, are you always checking for zeros to be in the range? Or would
Yeah.
it be okay?
Yeah.
0.
Yeah, exactly. That's why when I say here, x1 equals 0, that's that first 0, that's 0, 0, b. This one right here is the second 0 in the 0, 0, b. That's the only reason why I'm using 0 as my checkpoint, because of how it looks as a y-intercept, 0, 0, b. So if this 0 is not in this range and not in this range, forget what b is in terms of interpreting the problem.
Okay, so problem to problem, no matter what, you're always going to be looking if the zeros are in the range because the y-intercept is always going to be 0, 0, b.
There you go. Exactly. And so even though you get a B in your answer, like I think our B is what, 70, 75 or something like that. So even though I get a value for B, I still may not be able to interpret it in the context of the problem. All right. So I'm going to say if both are in the range, you may offer an interpretation. You may offer an interpretation. Now I'm going to go out on a limb here. Listen to this question. Hypothetical. Suppose x1 equals 0 was in the range of foot traffic. Suppose x2 equals 0 was in the range for minutes open. And let's say your B was still 75.09. Let's just imagine. Who thinks you can tell me what the interpretation would be in that situation? In other words, assume 0 is in both foot traffic, minutes open, and your B is 75.09. Can anybody figure out how you would interpret that? Think real carefully. Some problems that I give you, the zeros will be in the range, so you're going to know how to do that. So suppose you have 0, 0, 75.09. Yeah. Suppose this checked out, that checked out. How would you write it? How would you interpret it? X equals 0 in foot traffic means what? See, what you have to do now is interpret what 0 means in terms of foot traffic, what 0 means in terms of minutes open, and sales. Who wants to take a stab at it? Michael, any idea?
I'm thinking.
Okay.
So for 0 foot traffic,
Okay.
Sales would stay at 75.
Okay, that's good. That's a good start. That's good. That's good. Because see, this is good. You're saying for 0 foot sales, or how about this? When there is no traffic, there is no 0. So let's say when there is no foot traffic, and then in parentheses I'm going to say, so when you say no foot traffic, that's like saying x1 equals 0, right? When there is no foot traffic, and when what?
The store is closed.
Yeah, and when, because see, this technically means what? Minutes open beyond closing. and when there is, and I'm sorry, when stores do not stay open beyond closing. So this is when x2 is 0. So in other words, do you guys understand like what I'm struggling with here? Right, so I have to interpret what 0 means in the foot traffic column. Well, 0 in the foot traffic column means there is no foot traffic. Nobody's coming in your store between 1 and 2 o'clock. And then this down here, the second one, when stores do not stay open beyond closing, so that's x2 equals 0. No time open beyond closing. Sales are what? Predicted to be $75.09. Notice the difference here between this and interpretation of the slope. Because when we interpret the slope, we're holding constant the variable that we're not being asked about. But here, what we're doing is interpreting what 0 means in the first column, no foot traffic. Interpreting what 0 means in the second column, no amount of time open, the stores stay open. So you're going to have to be able to read that narrative and put on their means for that to be 0. And then notice here at the very end, when we did slope, we always said something like sales are expected to increase by or decrease by. But here we're saying that sales are expected to be that number. If everybody understand the difference? Like if I say your salary increased by $1,000 versus your salary is $110,000, right? So that's the difference. Here we're not saying sales are increased by $75. We're saying the sales are going to be $75. All right. So you sort of have at your disposal how to do it when neither of these holds. You know, you have to have both of these holding, right, in order to do something like this. If only one is in the range, if only 1 0 value is in the range, then I have to say I can't interpret it. I have to say that. But on the quiz next week, you know, if I give you some data and I show you, you know, I give you the data and I say, I don't know, the values are 5, 6, and 0, and then something like 2, 3, and 4, then 0 is not in that second range, so I cannot offer an interpretation for the y-intercept. All right, any questions on that? Any questions? All right. You guys are troopers. You hanging in there. You hanging in there. What's next? What does it say? Yeah, is the board clear for you guys? Can you see this? Can you see what I wrote there?
Yes, I just have one question.
Yeah.
What are the like the symbols above the 0, 0?
Oh, I just put a check mark.
Oh, okay, thank you.
In other words, I'm saying that it checked out that 0 was in the range.
Okay, thank you.
Because if there's an X by one of these, if that one doesn't hold up, then I can't do all this shebang here. 0 has to check out for the first column, and 0 has to also check out for the second column, or however many columns you have. Okay, moving right along. What's next? What does it say? Predict something?
Predict sales when foot traffic is 74 and the number of hours the branch remains open beyond closing is 12.
Okay. Predict. You guys know how to do this. Somebody tell me what strategy you think you would use. Just guess. What strategy would you use? How do we do this in simple linear regression? I told you to predict something. What did we do?
For the numbers and the values and so.
There you go. All right, so what is our equation? Y sub L equals, what was it? Oh, Lord. what was our equation? 0.93x1 plus 9.92x2 plus 75.09. And so again, I guess the good part about this is that you don't have to do this, summation that, square root this. Excel just gives it to you. Okay, so how would you do this? I don't know what number this is, but whatever number it is. Okay, so who answered me the last time? Can you tell me what to do here? Who was that?
That was me, sorry. I'm just pulling the sheet back up. It says the foot traffic is 74 south in the first X1.
Okay.
0.93.
0.93 times what here?
74.
74. Good. Plus
9.92, I think is times 12.
2 times 12.
And then plus the 75.0.
Very good. Very good.
Would it be 12? Because isn't it minutes and 12 is hours?
Is it hours?
Like number 7 says number of hours, but then like the actual problem says minutes.
Oh, I made a mistake. Yeah, thank you. Yeah. So in the question, change it to minutes. Yeah, that was my fault. That's my fault. Yeah, that's getting into a whole nother can of worms. Yeah. So the actual data is given in minutes, but then I asked the questions about hours.
Yes.
Okay. Well, yeah, that's a mistake on my part. If everything should be the same, yeah, I would never throw you guys a curveball like that. So yeah, so make sure this says minutes in the on the assignment. All right. So what does this end up being? What does this end up being? You have your calculators. And again, if you want to, you can write all these answers that we're doing on the Excel sheet itself, or you can just write it by hand. It's just when you go back and look at your notes, I just want to make sure you're understanding like what is what. So if you want to put it on the Excel sheet and look at it later, or if you just want to do it by hand, that's fine. Yeah.
Professor, the 74 and the 12, it's just a number within the range, right? It's not, we didn't calculate anything to get those numbers, right?
Hopefully when they give you these values, they are in the range, right?
Okay. I just want to make sure that I didn't miss a formula or anything to get those numbers.
Yeah. They were just given to you.
Okay,
right?
thank you.
Yeah, they would just give it to you. Yeah. So what do we have here? Anybody calculate? Anybody calculate? Yeah.
I got 262.95.
262.95.
Sales.
Okay, so that's going to be money. 6092. Anybody get something? Okay. All right. Good. All right. Simple as that. So you're praying for a question where I ask you to predict. Assuming you know how to get the regression line from the data, then it's just a matter of putting in those values. So everybody do the next one, which is asking you to predict again. Everybody do that one. Let me know what you get. I want to leave that right there. I think this time they changed the numbers. So same formula. And you can put in the chat box what you think your answer is. Nobody? Okay. Same. Everybody type something in there. I want to make sure everybody can Okay. All right. I want to make sure everybody's awake. Wake up. Wake up. Everybody type something in there. Wake up, type same, and then go back to sleep, I guess. I don't know. So everybody type something inside of there. Megan, did you type something in there yet? I want everybody. Kiara,
Yes, I did.
you did? Jaylene, oh, Jaylene's not here. Ashley P, did you type something? Is Ashley in here? Okay. So guess what? Nobody got it right. Nobody got it right. What's going on here? Anybody catch it? Look hard. Look really, really carefully.
Would the answer just be 0 because none of them remained open?
Not quite. Not quite. There's something else I'm trying to see if you see.
Would it just be $75.09 because none of them were open, and that's what it was predicted to be? None were open.
Not quite. What are the two values that I give you this time? What's the
62. Oh wait, but if it's not open, then how do they have foot traffic?
but I'm saying so this time, well, I gave you 62 and what? What was the other
0.
one? Oh, 0. Okay. 62 and 0. So, some of you are close, but it has to go to talking about the range. Okay, good, Sophia. Right, because see, so Sophia, why? Just take a stab at why.
It's because you're not given the minutes open, the second X value.
Okay, well, okay, it's related to that. So it's not only that you're not given right here, because I think the answer would still be you can't interpret even if I put a 1 right here. Because look at this 62. Is the 62 in the range of the foot traffic values that are presented? What's the low and what's the high? Is it in between there?
Yeah, the lowest is 29 and the highest is 110 for foot traffic.
Okay, good. So it checks out there. Now let's go over here. Let's put the 0 back. Minutes open. Is that 0 in that range?
No.
Okay, is even if I give you a 1, is the 1 in that range?
No.
Okay, so it's the same kind of check that I'm doing that I did before with the 0 and 0, but when it comes to predicting, I have to now look and make sure this number is in the range, and then this number, whether it's a 1 or a 2 or whatever, is also in that range. So it's the same kind of test, but when I'm dealing with Y interest, I'm only checking to see 0 and 0. But when I'm predicting, I'm looking to make sure this number is in the range and this number is in the range. If either one of them has an X that is not in the range, then I can't predict. That's all. Okay, so it's the same kind of test. So the reason why I gave you 2 separate problems like this one is predicting, because in the first case, I didn't say anything about checking to make sure that the numbers were in the range, but I think they were. What was this, a 12? I think this was a 12 the first time.
Yeah, it was 12.
Yeah, they were.
The range.
All right, and so I think when we did the check, then both of them were in that particular range, so then we could predict. So that's the only type of curveball I could throw in these type of problems. When I say predict this, students just immediately go right to the multiple regression equation and just throw the numbers in. Just always make sure you pause just for a second to make sure that both of these numbers fall into the range there. So the answer to this particular question is, like Sophia said, we're not able to interpret And if I say why, just say because the value given for minutes open falls outside of the given data range or something like that. Only curveball I really throw, really. So any questions on that? Any questions? All right, well, the last thing I want to do, on the paper, does it ask about the coefficient of multiple determination? Or no? Was that the last question?
That was it.
That was it? Okay. I think I'm gonna wait. No, I'm not. No, I'm not. Last one. So on this one, you're gonna have to add the question. So add the question, say something about like interpret. So what number would this be? Like 8 or something?
9.
9. Okay. Interpret the coefficient of multiple determination. Interpret the coefficient of multiple determination. And I'm going to say this is R squared. In fact, I think what I'm going to do, because I'm kind of tired, I think what I'm going to do is I'm going to write the definition of this right here for today, and then we'll interpret it after the quiz on next week. So you're not going to need to know this for the quiz, but let's at least define what it is. In fact, you kind of already know. And I just said multiple determination. Normally we just call it coefficient of determination, but in multiple regression, we have to throw that word multiple in here. All right. So I'm going to say definition. This statistic R squared tells you, this statistic R squared tells you the variation, it's almost the same as we talked about last time. The variation in the set of x variables tells you the variation in the set of x variables and how they explain the variation in y. You guys remember this from last time? And we may have worded it before. Remember how this is given as a percent? Well, we know R, then you square R, and you can write it as a percent. The only difference here is this. The set of x variables, right? So before, we would say something like, and I'll show you an example later, but I at least wanted to give you this definition. So again, R squared pretty much tells you how well the line predicts. But essentially what we're going to see next time is we're going to see how well the set of x variables, the variation in the set of x variables, predict or explain the variation in y. So whereas before we would say something like 95% of variation in foot traffic explains the variation in sales. The only difference is that we're just going to say now 95% of the variation in foot traffic and minutes open, all those X's together, how they explain the variation in sales or why. So it's just going to be a tweaking of the wording. But I'm worried about writing that now. We'll do that the next time. But just notice, like, the more X's we deal with, the more we have to sort of include them in the interpretation. But when you say the set of variables, I'm now looking at all of the explanatory variables there together and their impact on y.